Alright, hello and welcome back. Let's take a look at counting using sets and basic counting techniques. First things first, we will define the size of a set as n of A. So n being like the number of elements that are in the set A. So if I want to talk about how big a set is, I'll use that notation. And we're going to begin by looking at the inclusion-exclusion principle, which says that the size of the union of two sets is going to be the size of A plus the size of B minus the size of the intersection. And let's think about why this kind of makes sense. So let's start with our sort of typical diagram, right? U is the entire piece of paper, the entire universe. A is one set and B is the other. If we want to count all of the elements that are in the union, so that would be everything in A and B, well, what we can do is we can count how many elements did A contribute, so that would be this, everything represented here by the pink, and how many elements did B contribute. And you might notice that now the intersection is purple, and that's because we overlapped, right? We counted the things in the intersection twice. We counted those elements for A, and we also counted them for B. So what we've done here is we've double counted this middle part, the intersection. So we need to subtract the number of elements in the intersection once so that we can only count those elements one time instead of two times. Right now we're double counting. And so that's how we end up with this inclusion-exclusion principle. If I want to know, and so this equation that we have right here, you can use to solve for the size of any of these sets. So if you're given the size of the union, B, and the intersection, then you can figure out the size of A. So you can use this equation to solve for any of these, the size of any of these four sets. Let's go ahead and use the diagram that we've been given here for this first example. And we're going to try to find the size of some various sets based on the diagram that we have. Now let's just be clear for the diagram, this 14 that's in set A, that is representing the size of only the part of A that it is touching. So it's just this part over here on the left, this kind of moon shape. And the same thing is true for the 11 on the right hand side. That 11 represents only the part of B that it is actually touching. The 4 that we have in the middle, this is representing the size of the intersection between the two. And that will be consistent whenever we're using a diagram. The number that we're given will represent the size of the part of the set that it is touching. So we want to find, to begin, let's determine the size of A. So if we want to determine the size of A, that means we want to know how many elements are in the set A. Well, we know that there are 14 elements that are in A and only in A. And then on top of that, there's an additional 4 elements that are also shared with B. So altogether, A is going to have 18 elements. Even though 4 of the elements are also in B, they are still counted as being elements of A. So we need to include them in our sum. Let's take a look at the union. The union needs to be everything in A, everything in B, and minus the intersection. Now, we know how big A is, right? It was 14 plus 4, so that was 18. Similarly, B is going to be 11 plus 4, and then you can see we have too many 4s, right? So the size of A, and I'm using the inclusion-exclusion principle right here. The size of A was 14 plus 4. The size of B is given by 11 plus 4. And now we've counted the intersection twice, and so we subtract the size of the intersection, so we have a minus 4. Notice that essentially what we end up with, right, because we end up with a 4 and a negative 4 summing to 0, we ended up with 14 plus 4 plus 11. So that would be another way that you can find the size of the union if you have a diagram. You can just add up all the different pieces that you need. So let's see. 14 plus 4, that gives us 18, plus 11 will give us 29. So the size of the union would be 29. Let's see, what about the intersection? We can see the intersection from the diagram, that has size 4. let's see, the size of B prime, so the complement of B. Now remember, B includes, let's see, B was red. B is everything including that intersection. So the 11 and the 4 are included in B. So if we want the size of B complement, we want everything that is not included there. So we get the 14 elements that are in A but not in B, and we get the additional 11 elements that are in the universal set but not in A or B. So altogether we will have 25. So if you're thinking of this, if you removed B from your piece of paper, you would be left with the 14 in the little moon shape and the 11 from everything else. Let's see, A union B complement. So we want to know the size of A union B complement. Now remember, A union B was everything from A and B. So we have, looks sort of like glasses, right? Like eyes right next to each other. So A union B is everything within the black. So then the complement has to be everything outside of it. And in that case, that would be the remaining 11 that we have in the universal set. And last but not least, we want A intersect B complement. Well, the intersection of A and B, the intersection was in here, right? That was that 4. And so everything that is not in the intersection is in the complement. And so we end up with an 11 from the outside, the 14 from A, and an additional 11 from B. So we should end up with 36 total. Right? Okay, that's all for now. When we come back, we will look at using some basic counting techniques to count different things. All right.